through the initial training for the Intrepid software. I'm going to first just very briefly talk a little bit about Intrepid and then go through an introduction to some of the menus, supported file types that you'll find in Intrepid, and we'll go through just a very, very basic like import some data, grid it up, filter it, and then visualize it. I'll probably talk a little bit more in depth about the batch processing tools, especially the task files. Adam, you'll probably be familiar with job files if you're using Intrepid version 5. But we're actually deprecating those, moving towards these task files, which utilize the Google protobuffer format. I'll also talk about, just briefly, using the online documentation as well as the extensive cookbooks and examples that, that we've updated specifically for Intrepid 6.1. So Intrepid is an industry trusted package, and we've been delivering results to the geophysics community for over 30 years. We are a premier software for quality control, processing, filtering, gridding, and visualizing, especially magnetic, gravity, and radiometric data. We also offer comprehensive support for full tensor gradiometry, Falcon, and airborne electromagnetic data. And that's driven by our experience in the exploration industry. It was built to meet the needs of those industries and try to create a product that the best product for processing and quality. So let's talk a little bit about the Intrepid Project Manager. It's the primary interface where you'll launch basically a suite of tools and be able to access your different data sets and grids and so forth. It's been designed specifically to act like a Windows file manager, but it's best used with Intrepid's own data types and functions. It's made up of 3 separate panes, each which have a series of menus, and it's divided up. The menus are divided up into blocks of tools based on their geophysical processing functions. So you'll have a directory tree on the left, file list on the top, and a context-sensitive display down the bottom right. So as you can see here, we've got the directory tree, and you open and close the different directories, which almost like a kind of tiered structure, not much as Windows Explorer. When you click on a directory, for example, in this airborne electromagnetic cookbook, we've got the databases, tasks, and grids, and all the databases in here. You click on this particular database in your file list, and this context-sensitive display will change based on whether the file you've clicked on is a grid or a database or a task file or even a history file. In this context-sensitive display, as you can see for the database, you've got a few different tabs, and each tab will have its own little window with the fields. Demonstrate all the fields and aliases and so on. You can also get a little preview in the thumbnail that'll show you your data set spatially. So just a bit kind of retreading what I've said. As you'd expect with a kind of file manager, you can cut, copy, paste, delete, rename files, all that kind of stuff. And you can start up Intrepid tools as well. Run job and batch files directly from the file list. So if you right-click on a particular file, it'll come up with a little menu, and you'll be able to jump to certain functions from that. So start off with the project manager file options. As you can see along the top, there's a bunch of different groups with file, basically controlling the functions for the file you have selected. When you're doing batch processing with Intrepid's tools, you can open up a new command window, and this command window will have the path set to the currently selected directory within your directory structure. So this can be really good instead of having to kind of redefine a path every time from a command window opened just in Windows. This will have it all set up and ready to go for you, so you can make full use of Intrepid's batch processing. If you get a bit lost in the directory structure, you can also just show in Explorer, and that'll bring up a Windows Explorer window that will show which directory you have open within Intrepid in Windows. Other than that, we've got Open with System Editor as well. This Open with System Editor will open the file you've selected with the program that you've set as the default within Windows. So say if I've got a task file that I always open with Visual Studio Code, for example, in Intrepid, if I right click on it and go Open with System Editor, it'll open up a Visual Studio Code window with the selected task file open. You can also run your task files, all that kind of stuff through the file menu. Also, one thing is excellent for troubleshooting. The file menu also contains the log files directory. So if you go down here, log files, you can find the log files that are automatically generated whenever you run any sort of process within Intrepid. And this can help you when you're trying to debug a task file that isn't quite working correctly, or any other process. And quite often we'll ask for these log files when trying to help you troubleshoot a problem. So they can be really useful to know where they are. So if you go File, Log Files, you can open the log file directory. And we'll often ask for a log file from there. So Intrepid supports many different file types, but really we recommend people use the Intrepid data formats specifically, just because they work best within Intrepid. The Intrepid database format has the .dir extension, and it'll indicate Intrepid line, point, or poly database. The grid format that Intrepid natively supports is the ER mapper grid format with the .ers extension. Our batch processing tools, as I've mentioned previously, use the job or task extension. Adam, you'd know in the past we've used the job files for all this kind of functionality, but recently we've moved over to task files because it utilizes Google's protocol buffer language, but it also just makes it a lot easier for users to write these batch processing files out. There's also, whenever you run a process in Intrepid, it'll create a history file, which is a log of the processes carried out. If you want to make your own task files, what you can do is run a particular process that will output a history file that will have all the commands in task file format needed to run that process again. So you can use this to very quickly build your own task files if you don't want to start from scratch, which I recommend you go with this approach because it makes it a lot easier. You've got a starting point to work from. Intrepid also natively supports the DDF extension. It's a data description file, usually used for ASCII files. And it can be really useful to help import the ASCII files into Intrepid and convert them to a database format.
Tim, can I ask a question?
Of course.
So with the task files,
yep.
Can I say I'm going to start this particular bit of processing? I want to start recording the task file now, and then do that process and stop it recording. So I've got that task file. You know, like
yeah. So,
you can go file log files, and then there's a date there I can see.
Yep.
And then it's got stuff that I've done today. But is there a way of separating it so you just do the one particular process?
So your history file will output to your working directory, whichever directory you're kind of running your processes in,
yep.
Intrepid. And that history file will be a constant. So every time you perform a new processing step or alter kind of files anyway within that, directory, it will append the history file with that processing step. So it's never going to overwrite anything. You'll be able to scroll back up and find, okay, this processing step was used for this particular thing I did. And you can just copy that out, and you should be able to save it as a new task file and run it, and it'll perform that step.
Okay, yep. So just, copy it out using a text editor and
yes,
copy into a new file and save it. Yep.
I'd recommend Visual Studio Code with the CoffeeScript, I guess, option on, which will color code your code based on whether it's like an integer or string and all that kind of stuff. But the CoffeeScript works really well with the Intrepid task file format. So we recommend you use that to be able to visualize the task file really, really nicely.
Yep.
Does that answer everything?
Yep. No, that's good. Yep.
Yeah, good guys. If you have any questions, please just jump in. It's probably, there's only a few of us, so it's easy to do it that way. Okay, so Intrepid does recognize other formats like GeoSoft databases, but we recommend that you work in the Intrepid data format purely because it is our native format. It's just easiest to work with. So some of the supported data types include time series data, 1, 2D, 3D, fast Fourier transforms, Fourier series data as well, and that's in the spectral time domain. And spatially, I mean, obviously point cloud data, line data, gridded data, 2D and 3D, and unstructured meshes as well. We do have special subgroups for seismic, gamma ray spectroscopy, vectors, and tensor gradients as well. If you guys are sitting in on some of the later talks throughout the week, other guys will go into a bit more detail with the specific data types that you can use within Intrepid and how you can use them as well. There is one hidden file type within Intrepid. You won't be able to see it within the Intrepid project manager, but if you open up the same directory within Windows Explorer, you'll be able to find it. It's a .izzy file, and it's basically just a metadata file for any databases or grids that you import into or create with Intrepid. It'll contain information like data type, precision, null values, which field you're grouping by, and aliases for the databases, as well as data projections and statistics for any sort of any of the fields or grid bands that you have within your data. Sorry, it's all busy outside at the moment. I've got people running in and out, but we've gone through the copy, paste, and rename in the project manager. I mean, it's fairly self-evident, but we've had people ask this before. We don't support Office file types in Intrepid. Rudimentary task files, absolutely. You can see a short snippet within Intrepid, like Microsoft documents, PowerPoints, Excel files, we can't display within Intrepid. Any sort of ASCII files, we do, and you'll be able to see, as I said, a snippet in the context-sensitive display. And just building on that, no support for Microsoft Office file types. You can't, execution on any of those file types isn't supported either. If a file type is supported, usually you will see a little thumbnail next to the file name within the project manager, and that's usually a good indication of whether it's natively displayed. And you can just click on it, and it'll, you know, if it doesn't come up with any information, if the context-sensitive display doesn't update, then obviously it's not going to be supported. But just on that, if there are any common data types that you are working with that you find aren't being supported in Intrepid, please let us know. Because if it's being extensively used within GA and you guys need it for your workflows, I mean, it's important that we do support that. So let us know, and we'll try and work something out for you guys as quickly as possible. So back to the project manager. When you click on a database within the project manager, as I was saying before, the context-sensitive menu window will update to display a couple of tabs: the field, statistics, histogram, metadata, and thumbnail. And each of these will have information about the database. So if you click on fields, it'll bring up a little table with all the fields that are contained within the database. So it's aliases, data, and projection. You can delete or rename these different fields within the context-sensitive display, just by either to rename, you just double-click and then type in your new name, press enter, and it'll update it. Or if you right-click on the field name and you can choose delete, that'll delete it from the database. You can also set different aliases for your different fields. And this is really useful when you start getting a bit more advanced and utilizing the task files a lot more for automating your workflows. Because giving your database aliases will allow you to very quickly, the tools that you're using will recognize this field as, okay, so your FID has the alias fiducial, so it'll know that the FID field is your fiducial field when you open it in a particular tool. And the alias coverage is quite extensive, as you'll see in a sec. You can also set the datum and projection from here as well. You won't be able to convert the data and projection here. There is a tool for that. But if, say, it's mislabeled for whatever reason, you can click on them here and change those two parameters. So as I was saying, alias is used to distinguish which database fields should be used for the current processing task. It can be useful if you do use a projection conversion tool and change from one to another. It'll output new fields, so it won't overwrite the old ones. It'll just spit out some new ones. And then you can choose, say, which ones you want to be your X and Y coordinate pair. And that allows you to easily switch between the two just by changing the aliases for future processing, or if you need to output a new grid. And yeah, Intrepid will only load the coordinate pair for which the X and Y aliases are set, and that can cause issues if you're trying to grid a pair for which the X and Y alias isn't set correctly. So just be careful of that when you're gridding. Some common aliases and field names. So for X and Y, east, northing, flight number is flight, fiducial, line number, line type as well can be really good when you've got your primary flight lines that are you want to say grid up without tie lines, say. So you can have tie lines set as one particular value and your flight lines as another. Clearance, date code as well. Oops, sorry. And some tools specifically have the means to manage their own aliases within the tools themselves. But we recommend that changing them within the aliases column here is the best way to work with the aliases within Intrepid. So as you can see, you click on it and it will come up with a short list, and these are just the most used aliases. You can click more, and this will come up with a pop-up that has a larger number of parameter, not disciplines, but geophysics areas, I guess. Also, if you want to change the X and Y aliases, it will pop up the projection datum selection box. We do this just because usually when you're changing the X or Y alias, you're going to change the other one as well. And you can also here further set the datum projection. And the projection coverage is quite extensive within Intrepid. But again, if there is something that isn't, you want to convert to a particular projection that isn't being supported, let us know, and it's quite easy to implement that. Here's just listing out all the different aliases that you could set within Intrepid. And as you can see, it's quite extensive. And again, I feel like it sounds like a broken record, but we can add more if it's needed. It's just identifying the need for that kind of stuff. So some of the Intrepid tools are basically split up into behind the hood. There's the Java-based, and then there's not Java-based. Java-based tools will generally preload the data set that you have currently selected within the project manager. So it's modern, easy, convenient. Some of the older tools, especially the ones that are currently undergoing deprecation, or being superseded by newer tools, like the visualization, from the visualization tool to 3D Explorer. 3D Explorer is the new visualization tool for Intrepid. That will automatically open the data set you have selected when you open 3D Explorer. The older tools won't do that, but it's just a matter of, at the moment, a little bit of trial and error, but we're working on a solution to make it a bit more clear which tools will open up or preload the data set you have selected. Especially with the task files. Task files are generally always supported to open with the settings that they outline. So if I say load grid_spline.task, it will open the gridding tool with all of the options preloaded into the gridding tool. I think that's from there. So when you're getting started with Intrepid, there's really 4 core sources of learning material. There's the guided tours, and a fair bit of work has been done in this area recently, especially with 6.1 to make it more user-friendly. And we've added a whole heap of new examples as well for new users to play around with and get familiar with Intrepid's tools. So the guided tours are the cookbooks. We've got a whole heap of examples as well. In fact, we're not quite there yet, but the goal is to have an example for every single parameter that you could possibly choose to use within Intrepid. It's not, as I said, it's not quite there yet, but it's very close. So if there are any, as I was saying to Adam before, when you run a particular process, it'll output to the history file anyway, and you can also save your preloaded settings to a task file. So in that way, you'll be able to see in the task file uses these formats. So you know, when writing a new one, you'll be able to use the same kind of structure. But if you're having a little bit of trouble, look in the examples first, because more than likely you'll be able to find something that does what you're trying to do. And there's also on our website, we've got an incredibly in-depth documentation on each of the tools that are available within Intrepid, as well as some best practice for any of the processing you'd like to do. So to find it, you can find all the sample data, cookbooks, guided tours and examples in the Intrepid installation, directly under, you know, wherever you install it, find Intrepid, version number and the build number. And then you'll have the directory structure within that. It'll be under sample data is what you want. So under sample data, we've got cookbooks, examples, guided tours. You'll also find documentation about these under help. So documentation will take you to the online documentation on our website. Protobuf documentation I'll go through a little bit later. And then you've got the general reference, tools reference, cookbooks, which will take you specifically to the documentation relating to the cookbooks examples, and guided tours. Just online documentation. You can go through it through the help drop down in Intrepid. It also can be just found at our website, intrepidgeophysics.com/documentation. And it just looks like this. So we'll just go through an incredibly basic kind of workflow, importing a line data set into Intrepid, then we'll grid it up, then we'll apply an RTP filter, and we'll visualize it. So there are 2 ways of importing data into Intrepid, using the import tool. And the import tool provides the most functionality for Intrepid and has a whole heap of different options for importing. Then there's the ASCII import wizard, which it enables very rapid importing of ASCII data, especially in the ASEG GDF2 format. Both modules are found at the dataset heading in the project manager. And Intrepid supports several data storage formats natively, such as the Intrepid database, GeoSoft database, and most common relational databases as well, like Oracle, PostgreSQL. Other formats will need to be exported or imported into GeoModeler. Sorry, not GeoModeler, Intrepid. Any line data sets that you import into GModeler will be stored as a group. And it's a general concept, usually aligned, but it doesn't have to be in lines. You can have like polygons or I guess anything you can think of really, but generally we use it for lines. And the group by field orders the data by that field. And it should have a unique value per group. With the point data sets, we don't have any concept of grouping, or it's not enforced by Intrepid. And as you can see, in the project manager, under the fields tab, it'll tell you which field you're grouping by. So in this case, it's by line number, which makes sense for a line data set. So just very quickly, I'll go through, you can all see the Intrepid project manager here, I think. Is that correct? I'll assume that's a yes. So we're going to import this data into Intrepid, and we're going to import it as a Intrepid database. So we'll, as you can see, it's in delimited ASCII format. So we're data set import. And I'm going to go File, Open Input File, because as this is one of the older tools, so I won't preload your data that you've selected. So we're going to choose this one, sangmag.xyz, click Open. And we're going to set the input vector format as ASCII line XYZ. And then we're going to set the output data set. I'm just going to say imported data set. And I'm going to import it as an Intrepid database. So click Open and then hit Apply. And that'll give me a message saying the import process is completed and just a report of what happened. It's about to do it and it's finished. So I can close that, click OK. Now it will ask me for a projection and datum, because it didn't find any within the file. X and Y aliases are set, so that's all good. So I'll click on projection. I know this is transverse Mercator. I'll double click on it. And it's, where are we? UTM zone 51, north. Click OK. Open that up a bit. The datum, I know WGS84. Click OK, and I click OK. So that's good. I'll close that. Now you can see our imported data set here. It's currently being modified. Now we've got X and Y with the datum and projection, line type and line number. And we've also got our field here. Now, it didn't find a field name, so it's just named it as field 1. I'm going to change that to total magnetic intensity. Hit enter. As you can see here, it's changed. It's reordered based on alphabetical order. And I want to change the alias to TMI as well, because I think that'll make it a little bit easier. So I'll click on the alias field here. Scroll down to more, because I don't see TMI here. And then we'll go magnetic field and see this. We've got the TMI here. I want the TMI field. I probably should have called it something different just to make it a bit easier. TMI field is given the TMI alias. We'll click OK. Now we've got the alias here. Okay. And sorry, something I didn't mention before as well. With group by, you can have multiple group by fields. So it'll group based on those multiple fields. Just be aware that it will increase the size of your data set every time you set a extra group by field. So we're working with extremely large data sets, can make it a bit difficult. So just be aware of that. But now we've imported our data set. We can go have a look at it in 3D Explore. So I'll go up to Visual 3D Explore. And there we have it, geolocated, or lines there. We can change the signal field, but we're happy with TMI. That's what we're trying to look at. You can change things like stroke size, aliases, all that kind of stuff. But I won't go too into depth with 3D Explorer at the moment. But just quickly, there are other, beyond the Fields tab, there are a couple of others as well. We've got Statistics, which will give you just some very basic statistics about the field that you've got selected. So if you go to TMI, give you the number of samples, minimum, maximum of the field values, mean, standard deviation, and so forth, and a number of nulls as well. You can also click on line stats, and it'll give you the stats per line. So we've got a whole bunch of lines here, and it'll tell you the amount of samples and maximum for each line, rather than the data set as a whole. We've also got a histogram that'll show a histogram of our data. This is just as a snapshot. There are much more in-depth tools to display histograms, the statistics, all that kind of stuff within 3D Explore under Visual. But this is a good way to just very briefly check on your data, see that it makes sense, nothing weird's happened. Yeah, some metadata and the thumbnail as well, which will just give you a very brief view of the data. So you can choose the field that you want to visualize, and this because we've set the aliases for X and Y, it'll always display like this no matter which field we choose. So we can choose X and it'll show as the easting changes as we go from left to right. The color value will change. So just make sure when you're doing that very quick check, you've got it on the field that you want. Because we set TMI as the alias for our TMI field, it's defaulted to that in this kind of little thumbnail. Let's go and grid this data set up now. So click on gridding and then gridding. Okay, so with the gridding tool, you can see I've had this import data set selected already. And when I open the gridding tool, it's set the input data set as this. The X and Y fields have pre-populated because I've got the X and Y aliases set. So with the datum and projection, data set to TMI. And as you can see down here, we've got the input visualization. So we can see the bounding box for our grid around our data. And it will automatically scale the grid to encompass all of the whole data set. You can obviously clip it out for a particular area that you want in the output grid. But we're just going to leave it as gridding the whole area to start with. So I go to gridding method. I want my extrapolation limit to be set to 5. cell assignment closest. We're going to use the nearest neighbor gridding method. So I'm happy with all of this. Grid refinement, I won't go into too much detail here, but I'm going to leave them all as defaults. If there are any holes in our data, I just tell it to fill those. It's our edges. I can limit the edges of the grid nulls to the original data limits, but I'm just going to say extrapolation limits for the moment. Now we'll go to output grid. It'll default to the working directory, and it'll take the name of the input data set appended with the field name that we're going to grid. And we're automatically gridding to the default ER mapper format within Intrepid. There's only one band, so choosing the first band to output. These should all be standard for Intrepid. If you've imported it using the import tool, null value will be a negative 99,999. You can change this if you like. You can set the rotation as well. We're just going to leave the origin and the extents, number of cells for the moment, because otherwise if we start cranking up the cells, number of cells and reducing the cell size, it might take a while. But if you play around and you're not happy with it, at any point you can just reset, click here, reset the extents, and it'll reset the gridding area back to this first value. So we'll hit apply. And then it'll give us this little output grid. So I'll close that. Now we have our output grid. I'll just want to perform a reduction to poll as well. So I'll just do that very quickly as well. We'll go to grid FFT. So it'll be in a filtering grid FFT. I've got it selected, but when it opens up, it'll ask us which grid we want to filter. We'll choose this one that we've just gridded. And this will bring up the grid filter tool. So we've got our input grid data set here. It's the one we've selected. We can save the various products that are created during the filtering process. So we can save the FFT of the input grid. When we're doing the grid conditioning as well, we can remove trends that we'll add later. We can expand the FFT border as well. Put in a roll-off to reduce kind of ringing artifacts when you've got a very sharp boundary on your grid. And save intermediates as well. So it'll give you a bunch of different intermediate products that you can output and choose the directory of. So you can create like a basically dumping ground for all your intermediate products if you want to be able to go through them and see a particular stage within it. We're not going to do that. We want a reduction filter. So we'll add this, so we'll click on it, then we'll add the FFT filter to the filtering process, and that'll put it in after the grid conditioning, but before the grid restoration. Now, our inclination and declination are automatically calculated from the geolocated grid. I'm not going to play around too much with this because I'm assuming you guys will be comfortable with all this. And we'll go reduction to poll, and we'll just do average RTP. It's not the data set isn't big enough to use the variable RTP, and that'll take a while. And we won't add a directional cosine roll-off. You can do this here, or you can also add the cosine roll-off as its own filter. And you can also basically stack filters into the one process if you'd like. Okay, then we'll grid restoration. If we've taken a trend out of the grid, we can reapply it on output. Otherwise, we haven't taken the trend out, so we're just going to leave that. Output grid, it'll output to the working directory with the grid name and append it with filt. I recommend changing this because any filtering process you do will just append it with filt. So just say RTP. It can be confusing to keep track of when you do lots of, you apply lots of filters and they're all just appending with filt1, filt2, all that kind of stuff. But it's just there as a placeholder. Then we'll hit apply. That needs a bit of decorrugation, I think. You can see the spectral image view, as well as power spectrum as well, of the grid. We'll close this. It's quite streaky. For purposes, we'll just go visual and 3D explore. You can turn interpolate off. Rotate our grid. You can use the Z-axis as well to enhance trends within the grid. So this will just allow you to see elevations, or you can change the elevation file to your DTM if you load it up, and then drape the grid over the top of it, so you'll be able to see how it reflects the elevation, and so forth. Close this. We'll come back to the PowerPoint. If I can open it up. Okay. Now, what's the time? Do you guys want to have a short 5-minute break, and then we'll come back and go through the task files in a bit more depth? And
yeah, that sounds good.
Yep. Okay, fantastic. Well, we'll have a 5-minute break.
Yep.
And then you know, go to the toilet, do whatever you need, and then we'll come back and go through a bit more. We'll go through yeah, batch processing a bit, and I guess you guys can ask a few questions about yeah, whatever you like. Okay.
All right, cool.
Cool.
Easy. just wait for Adam to get back, I think it is. Then we'll keep going.
Yeah, I think that was Adam.
Yeah, cool. Do you guys have any questions or comments or anything? Just while we're waiting for him to get back.
No, so far so good.
Yeah, I'm all good too.
Okay, easy.
When you're trying to get an overview, yeah.
Yeah, it's I don't know. There's a lot to learn when you first get started. I've been in Intrepid for about a year now, and there's still things I'm getting my head around. But
I mean, some of those things seem, if the grid is fine, there's no issues, probably pretty easy to get some simple filtered images out of it.
Yeah.
But for example, when would you take a direction out? Things like that.
If do you mean like trends?
Yeah, trends and stuff like that. Yeah.
I'm not actually sure. I'm a airborne electromagnetic specialist, so the extent of my gridding is really in like DTMs. But I guess it depends on how a trend might be introduced through I don't know, a particular bias from the instrument or
Okay.
yeah. I'll get an answer to that question for you. So you were Michael?
Yeah.
Yeah, Michael. I'll get a question. I'll get an answer.
Oh, that's all right. If it doesn't apply for magnetics, which is probably my main interest.
Sure.
That's okay. But I was just wondering when to do that. I won't get a feeling whether how often these kind of non-standard kind of problems occur, and I understand you that's very uncommon for magnetic data sets.
Yeah.
Okay, that's good.
Yeah. Okay, we've got Adam back, so we'll continue. So now just talk a bit about the task files within Intrepid, especially running and preloading. So we use the task files to automate workflows within Intrepid. Many of the tools will actually allow you to save your options as after you've set everything up. So you load a data set, you set the parameters to what you'd like. Before running it, or even after running the tool, if you go to File within that tool and then Save Options As, it will output a task file with all the parameters set up as you've selected. And these task files can be run using batch processing. You can either do this from the command line or by selecting Run Task File when you right-click on the task file and then follow the drop-down menu. If you right-click and then choose to Open with Task, it will open up the GUI with the parameters and values from the task file added to the GUI. So this can be really good, opening with the GUI if you've got all your parameters set, but then you think, oh no, I want to do this process this particular way, but I want to change one parameter. Well, you can open with the task file and then modify it within the GUI and then see the result. Otherwise, you can just change the parameter itself within the task file. It's easy enough as well. If you want to run from the command line, my recommendation would be, as I was saying before, to go File and then open command window within Intrepid, because this will have all the paths set correctly. So all you need to do is type in fmanager space dash batch space and then the name of your task file, and that will run. As for what's new with Intrepid 6.1, we've got full implementation of task files. Adam, I think you were saying you just have job files, I think. Task files have kind of been added over time, and we're at the point now where we're completely using task files, and job files have been removed. Sorry. There is a way to convert job files to task files automatically. If you right click on the job file, it'll have an option that says convert to task. This is useful as a starting point, but I don't rely on it to convert all your job files over. It will still need some manual adjustment, because the format of both files is a little bit different, and it doesn't always match up one-to-one. We still doing a little bit of work on the converter, but I think it will always need a little bit of manual intervention to fully transition from the jobs to the task files if you're using jobs already. The cookbooks and example task files have been completely restructured, predominantly to get new users up and running more quickly. It's now set out into various geophysics disciplines. So if you want magnetics, all the magnetics cookbooks are kind of together, radiometrics is all together, and set out in a logical kind of workflow. We've also got work's been done on the mag transects tool. So now you can now have diagonal transects and include elevation data within your processing. And radiometrics tools now support 256, 512, and 1024 channel spectra. The GPU can be used to visualize glyphs and shading in 3D Explorer as well, which takes a huge load off the CPU. I think it was before this was implemented, glyphs especially were incredibly clunky within 3D Explorer, but pushing that to the GPU has allowed pretty significant performance gains in that area. And there's been improvements to the usability of the equivalent layer tool. And now also there is workspace persistence in 3D Explorer. So if you've got a workspace and you close it, you try to open it again, all your settings will persist. Now, yeah, go.
Yeah, sorry, what is a glyph?
A glyph, sorry. So a glyph is a three-dimensional representation of some data. So it will usually take the form of a vector within 3D Explorer. So you can give it a location and direction and magnitude. The visualization of those has been greatly improved.
Okay, so it's like a 3D vector.
Yes, correct.
Okay.
Now I think from here, I'll go through some of the cookbooks that we've got, and maybe some of the examples if you guys want to see particular like workflows or particular tools. And yeah, if you have any questions or anything, you know, now is kind of the time where we can go through it a bit if you like. Is there anything in particular that you'd like to see, or should I just kind of go through a couple of the cookbooks and show you some of the examples, or how would you guys like to, what would you like to see?
Yeah, probably if we start with magnetics.
Yeah, of course. So I can open up this. So we've got up here, you can see we've got the aircraft compensation, equivalent layer, interpretation, Euler deconvolution, edge detection, and then now the auto model. Adam, this would be a little bit different to Intrepid 5 version. Is it 5.6 you have?
Yeah, I've got 5.6. Yeah, none of that
Yeah,
stuff
sure.
is
So
there.
all of this has been extensively restructured just to make more sense within each kind of discipline. Maybe magnetic compensation we'll go through. So we've got each kind of processing, say, step is split up into the components of the databases. We still ship all the old job files, though, or maybe not for this one, but this is basically for historical record keeping, I guess. The job files won't work within the new Intrepid 6.1. So we've got two databases here. I don't actually go. So you can see it very briefly. Oh, sorry. Is there anything in particular you'd like to see from magnetics, like trend gridding or compensation, or?
Yeah, sure. Trend gridding would be good. Yeah.
Trend gridding would be good. Okay. Let's go Baker 1. Magnetic grid. We've also got the intermediate grids, so you can see what they should look like when running the task files. So maybe we'll have a look at this one first. So these are the different task files that'll complete different processing steps. They're usually labeled depending on what they do. As you can see, you click on it and it'll come up with the task file here. For the longer task files, you can scroll down a bit and then it'll say, that it goes on further and that you'll need to open within Visual Studio. So if I right click on it, you can see if I open with registered app, I've got Visual Studio code on here, and it'll open up in Visual Studio Code. Oh, go away. And instead of plain text, if I use CoffeeScript, that is probably the best kind of language mode for the task files, because it nicely highlights like different parameters or methods and all that kind of stuff. So I'll run the task file, and it'll say it's completed, and it'll give us history as well as our output grid. I'm not sure with this particular one. We've got basically for each, I guess, different thing you'd want to do. So create TMI from horizontal gradients observations. It's taking in an X component and a Y component, outputting a TMI grid. If we go, let's maybe mag gradients. So demo of gridding can take a wingtip magnetic gradient and enhance TMI grid. So just stepping through the task file, you can see we have our input data sets and input X and Y as well as the data, survey lines, and it'll all be split up. So we've got the task, the Intrepid task, then gridding, so it uses the gridding tool, input data sets, so this will outline the different parameters around the input. Gridding method will, for the gridding method parameters, outline all those, and then have a grid refinement and output. I'll just after I run this, I might very quickly just show you as well for the task files, the Google protobuf documentation. We'll run this. we can either run it like that. So task completed, and it'll give us a data set here. So we're done. Oh, this is our grid that we've created. That was nice and quick. With datum projection and everything here, statistics and a histogram of the signal field. Just very quickly, if we go up to help and protobuf documentation, and I'll drag this back over here. So this will bring up a table of contents with the protobuf documentation. So we're going to be specifically looking at Intrepid tasks. You can see there's a whole bunch of methods in here. If I go back to the Baker mag gradients, we'll see the gridding here. So if I go Control F, type in gridding, I go back up here. So we've got the gridding method, two different gridding methods here. We'll click on the first one. So this is for the main gridding tool. I'll make this a bit bigger actually, so it's others. So when you writing your task file, if you're having trouble working out what different parameters you can include or what should be available, we'll see here you've got the gridding method, and you can see under gridding there's these. Sorry, get rid of that. These different parameters. So we've got input data set, pre-processing, grid refinement, all that kind of stuff. And if the input type is not a string or a Boolean or integer, it might be call another method. So as we can say, grid refinement is the, I guess, top level after Intrepid task. If we click on, say, we've got this input data sets here. If we click on input data sets, it'll take us to this method and the different parameters that we can use within the input data sets method, and so on. So we'll go back. And going back will take you to the method that you were viewing previously. So if you're not sure of a particular parameter or the correct spelling or anything, this has the most information about it. It's got a name, the type that it's expecting, a label. So it'll either be optional or required for that particular method. So if we have a look somewhere for required, so the grid for grid FFT method requires you to have some sort of input grid name, but all the other parameters are optional. And it'll give you, in these notes here, it'll usually give you a default value for either the output or what it will be if you don't specify anything. Yeah, so that's the protobuf documentation. Yeah, I'm not an expert on magnetics, so I may not be the best person to help you with the magnetics tools. Are you going to be in any of the other training sessions, Adam?
Yeah, I think pretty much every day.
Okay, great. Well, I'm not sure which day the magnetics was, but they might be able to go through in a bit more detail some of the magnetics stuff. Did you have any more questions about the task files or anything in that regard?
No. I think I just checked my email and I've got the what do you call it? I've got the key now for version 6. So okay. Yeah, what I'll do this afternoon is I'll look at these cookbooks and try some of the task files myself. Yeah,
have a play around with it and see what you can do. Yeah, and also as well, if you try converting some of your jobs to task files. And if you have any issues with them, bring them up in the magnetics training when they're kind of asking questions, because yeah, it's the transitions from job to task might be a little bit rough.
Yeah.
So yeah, just the smoother we can make that, the better.
Okay.
Yeah. Do you guys have any other questions of things you want to see, or any questions about using Intrepid or anything like that?
I have nothing specific. I'm happy if you just give us a browse through what you think is, of interest for an overview.
Yeah, I agree.
Yeah.
Okay.
Yeah.
Well, maybe we'll have a look. I'll go through maybe some of the example task files then, and then run them. With the guided, I'll just go into a little bit with the guided tours. The guided tours doesn't really have, the idea with cookbooks is you can kind of open it up and have a read through, maybe not that one, we'll go gravity, say, go land, have a look at some of the tasks here. So they'll have some numbers about, like, you should run this one first, then this one second. So the cookbooks are a bit more self-contained, whereas the guided tours, if you're just starting out with Intrepid, I'd highly recommend going through the guided tours, and that's if we go to help, guided tours. Oops, sorry. If you're just starting out in Intrepid, this is the best way to gain a bit more familiarity and start off quite easy, because this will have the much more structured workflows. The cookbooks are good if you want to say, oh, I want to be able to do this particular thing quickly, like I'll do, what's this? C filter, perform convolution on a grid with a specified kernel filter. You can browse through the task files and say, oh, okay, I want to do this particular thing. This is how you do it within the task file. Whereas the guided tours will take you through step by step how to do what you want to do. As I was saying before, the examples, we open up, got a whole bunch of data sets. The most important parts of the examples are data sets and tasks. We'll click on tasks as well. This will basically go menu option by option. So we'll have data set first. If we open up data set as well, go export, import, merge, resample, and subsection. We open up each of these and it will have exporting just a regular data set. So we want to import, so we'll go through different types of data sets like NetCDF, ASCII data sets. So these are more targeted to specific problems rather than as a general overview. Yeah, I guess maybe we'll show magnetic transect. So I've got bear with me one sec. So one of the new tools within Intrepid is the magnetic transects. I actually use the cookbooks. Sorry, I'll just find the one I'm looking for, and then we'll be good to go. Be magnetics. Oh, modeling, sorry.
And the other thing is, I mean, the other thing is, you know, because it is dangerous to walk to when you just use the size.
I thought it was in here. Maybe have a look at mag transects. So this is a fair bit of work's been done on this tool. To be able to, as I was saying before, have diagonal transects. It used to be only north or south. We can now, we want to change the angle, 45. Oh, sorry, haven't got my num lock. Okay. Change that. Other way. I've got this here. So we've loaded up our input grid, and we're able to interactively change our transects and the length of them and everything. So I'll just maneuver them so we get nice. Maybe I'll go 30. No, other way, sorry. Okay, I'm just going to leave these as defaults, but you can change. It'll take account of your elevation grid. And you can use, you know, set cut-off frequencies, all that kind of stuff. Change the opacity of your grid. And we're going to just output to a voxet. So run that. So I'll have this little interactive viewer. As it's running, you'll see these change to green. It might be a bit difficult on the screen. So yellow, we haven't calculated yet. Green, you can see, got the mag transects. We can go along each one. So depth and power spectrums, all that kind of stuff. If I close this.
Sorry, what is it showing there? What is it showing in the depth?
So it's using the depth spectrum to basically calculate the depth of a magnetic body. So
the dark line is the most likely depth?
That's correct, yes.
Okay.
Have you used any like magnetic transects processing tools before?
No.
No, okay. It's still not experimental, but quite new as a tool. But yeah, finding it useful to model the depth of, and just because it's the depth of the top of magnetic bodies.
Okay.
Yeah. Close. So that's finished running. It's quite quick, but usually you want quite small windows and quite long lines, and especially as well when you get close to edges, it might have a bit of trouble because it's starting to take into account nulls around the edges. So I'd just be very careful with that. But we're currently implementing a threshold so that if there's a certain number of nulls around a particular transect, it will basically cull that transect and say, "Oh, it's not a viable. It's not viable because there's when there's nulls around it, it's got to not estimate, but interpolate. I guess it's a form of estimation. interpolate across the depth, the spectrum, and that can cause issues, especially if you're you don't have many data points within your power spectrum and depth spectrum. So yeah, we're currently working on ways to address the transects that are close to the edges of the grid. I don't know. Do you guys know? I guess it's maybe not relevant to what you're doing. Do you guys know if it'll be easy to get new builds to you, or
to get what's right, new builds?
New builds of the software. So if we make an improvement in some respect.
Oh, not really.
Yeah, if we hassle them, they'll do it, but otherwise it's kind of slow.
Yeah, sure. No, that's okay. I just thought, well, yeah, because we're going to be able to provide you guys with, features or improvements that you need. So yeah, maybe I'll have a chat to the guys here, and we'll try and work out a way to be able to get that to you if it's required. Yeah.
So sorry, for the magnetic transects, is there documentation about how?
There is. If I go to the documentation here, yep, that's right. So it's still fairly brief, as it's a quite new it's quite a new tool.
Yeah.
But it'll take you through the basic theory and how to get the most out of your processing as well as like a task file example.
Yep.
Yeah, if this should answer the questions you need. But also guys, like if there are any tools that you feel aren't you need more information on, just send us an email. We're happy to help you out and work through that kind of stuff. So I think, I'm not sure if you'll be provided a particular email, like the support email, or you'll be emailing team members individually. But yeah, if anything's not clear, just let us know. Was there anything else you'd like me to show, or is that kind of it? It makes it difficult, I guess, when you don't have the software in front of you. I'm not really sure what to show you without I guess without knowing what particular things you guys are working on. Adam, you said magnetics.
Yeah, is there a line leveling magnetics?
There is in the leveling tool. This is kind of crossing over into territory that I'm not particularly familiar with. I'm sorry.
Okay, that's right.
So maybe the person doing the magnetics training would be best to talk to about that. I'm sorry to kind of defer so many
That's
questions.
all right. Is there a cookbook for it, or a
yes, yeah,
example?
absolutely. There'll be, in fact, I think. Documentation will go. Sorry to just bring up the documentation and go through for each kind of question. We've got like tile line leveling,
yeah,
line correction. So there's quite in-depth information through here.
Okay.
About it. Liam or Michael, did you have any other questions or particular areas of interest?
Not really. I want more to get an overview of the program. I'm not a geophysicist or geologist to interpret data, so I kind of want to get a feeling whether it's worth for me to get some hands-on experience to be able to, do some image manipulation quickly and stuff.
Sure.
One thing I would be interested, because that would be something I would have to deal with, is merging of different magnetic surveys and grids.
Oh, sure. Okay. Yeah, absolutely. Well, I'll just go. Can actually just go, so merge data set. We can append lines or points. When it says append lines or points, it's basically just meaning append to the database. So we'll go. This one. And we'll just say, grab, put here. Okay, and we'll just run it. Completed successfully. So we'll go to the examples, data sets. And where is my output? Output is here.
Mm-hmm.
Those are the two databases. We've got this one and this one.
Mm-hmm.
So you see it's the combination of the two.
Yeah.
Yeah. And that's how you'd merge the two. You can start merging points and fields, but if you just want to have two databases and have them within the same database, you go about by appending lines or points.
And then I just grid. So in this area where I have overlap and stuff, where there's much tighter line spacing and stuff, how do I go about that when I grid then?
You'd have to take that into account when you're creating the grid. A better way to do it in that case would be to grid each area separately. And then we've got the grid merge tool.
Okay.
And you can use the grid merge tool to merge the two grids together. And it's designed for a large number of grids of varying quality. So what it'll ask you to do is, I mean, the best way to do it is have a play around with it and see, because there is again detailed documentation on grid merge specifically, because it's quite a, it's been in Intrepid for quite a long time. But what it'll do is it'll basically ask you the hierarchy of the grids from like best quality to worst quality, and it'll prioritize the grids that are of high quality when merging the two. And you've got different options to merge them and like feather merge them as well. So
okay, so gridding first, merging then later.
Yeah.
Cool.
So that's the best. That'd be the best way to go about that problem if you wanted to grid them up as well.
Excellent.
Yeah. Anything else? Liam, do you have any questions?
No, I'm all good.
I'm good. Easy. Michael or Adam, do you have anything else you'd like to talk about?
I think I'm good. Adam, go for it.
If there's nothing else you'd like to talk about, maybe we'll call it a day. If there's anything else you can think about, or questions that you have after this, let me know. I'm more than happy to ask it. My email address, maybe I'll type it in the chat.
Send us an email, I think, before.
Yeah, that would be the best way to do it, actually. I'll send you an email. Just
you did send us one, I think.
Oh, of course.
There's a link, yeah.
Of course. Sorry.
Right.
Well, just send me an email through there, and
cool.
Yeah, I'm happy to answer any questions. Any that I can't, I'll refer on to the team, because we've got some geophysicists who are a bit more experienced in some of these areas than me, especially like Adam with your magnetics. I think Rod here is extremely experienced in that area. Yeah. Otherwise,
Anyway.
we'll, if you guys are happy, we'll maybe wrap it up.
Sweet. Thanks, Tim.
Yeah. Cool. Thanks a lot, Tim.
No
Also
problem,
good.
mate. Thanks for coming along, and yeah, I appreciate you guys listening to me talk for an hour, hour and a bit. But yeah, as I said, if you got any other questions, please feel free to pass them on. We'll be happy to answer them.
Thank you.
Thanks. See ya.
Thanks, guys.
Bye.
Have a good day.